Hello, it's Marc from eSgoil. This is the first of two videos looking at SQL in higher computing science. In this video, I'm looking at everything except the aggregate functions. We're going to review the types of SQL statement that we can use, select, delete, update and insert, and also look at the where and order by clauses. We'll also be looking at the use of wildcards within our statements. We'll look at how we can create new values in our database called computed values, which are sometimes called calculated fields, and how we can give friendly names to them using aliases. We're going to look at different kinds of SQL statement now. You need to know the correct syntax for the statements. A lot of mistakes in exams come from people mixing up insert and update syntax, for example. The most basic of statements is our select statement. This will return all fields from all records in the pupil table. The star in this case means all. When we display data using a query, a temporary table is created known as a result set. Of course, at National 5 level, we learned we could use specific fields in our select statements. In this example, we're selecting first name and surname from the pupil table. At National 5 level, we also learned we can use the order by clause to sort our result set into ascending or descending order using the ask or desc commands. If we're sorting text, it will be alphabetical or reverse alphabetical. We also introduce conditions into our select statements using the where clause. In the example below, we have a condition that shows the first name and surname for any pupil whose last name is equal to Skywalker. We can use a delete query to remove a record or multiple records from our database. We have to be careful when doing this. There's no way back except from backups if we do this in a live database. Note here that you should have a where clause picking a primary key to make sure you're only deleting a specific record. Insert queries are used to put a new record into your tables. You can list the specific fields in the into clause, but it's not required as long as you list the correct number of fields in the values clause. The query below would insert Ben Solo into the table. Update queries are used to change the values associated with records in our tables. In the example below, I've updated the pupil with the primary key GW15 Ren Kylo. I've updated their first name and surname. You should always update records based on their primary key so that you don't cause an update error. We're now going to look at wildcards. We use wildcards to match incomplete strings in a query. This could be because you want to return multiple different values or because you don't actually know the full string that you're searching for. We use wildcards to make up patterns where characters can be substituted. We use the SQL operator like to do this. Just a quick note that wildcard symbols differ in access to most other flavours of SQL, but both of them will be accepted in the exam. We're going to use the % symbol and the underscore, but in access you would use the star and the question mark. We can use the % symbol wildcard to state that any number of characters can replace the symbol. In the example below, a Glow username can return any number of characters after GW1. In the example below, I've used two % symbols to state that any number of characters can come before and after the word sky in a Glow username. Unlike the percentage symbol, an underscore can only represent a single character. In the example below, we've used two underscores to represent two digits that can follow GW in a Glow username, followed by the string Skywalker Luke. It doesn't matter that we don't know the numbers. We'll return any Glow usernames which have GW, so any two digits, and then the string Skywalker Luke. Like before, we've represented the two digits after GW with two underscores, but now we can return any Skywalker in our result set by adding a % symbol after the string Skywalker. We're going to move on to looking at computed values and aliases. An alias means another name that someone uses. For example, many writers and actors use aliases, like J.K. Rowling, who also writes under the alias Robert Galbraith. In databases, we use aliases to give column names and result sets different names, often to make them more readable or to indicate a purpose for them. This is useful when we are creating new data with computed values as well. We use the as command to create an alias. If an alias is only one word, we don't need to wrap it in anything. However, if it's two words, like below, we need to wrap it in square brackets. In some flavours of SQL, quotation marks will work as well. In the example below, I've changed the first name and surname to be a bit more readable in the output using aliases. Computed values are a bit like doing all the simple operators we did at National 5 level programming, but in databases instead. We can create new data and result sets by using operators. Note in the version of SQL that I use, I'm using a double bar to concatenate. This symbol is sometimes called a pipe, and you can find it by pressing Shift and backslash. And here's the concatenation that I was talking about. First name, a space, and surname are concatenated with the alias full name set in this example. And here's a proper calculation as well. It's a bit of a made up one, but it should show you how we can take a value in our database and use operators to calculate a new value in our result set. In the example below, I've taken the field midichlorians and divided it by 3 and then gave this the alias horsepower. Here's a summary of everything we've looked at